Hello, now we're going to continue our work in coordinate geometry and we are going to have a look at the angle between two lines. Now there are going to be two angles between any two lines. If I draw a rough sketch here, I have two lines crossing each other. I'm going to have a smaller angle here. This angle is going to be, we would say it is acute because it's less than 90 degrees, and we have another bigger angle between our two lines, which would be the obtuse angle. And we're going to look at a formula that gives us both of these angles when we are looking at lines in coordinate geometry. So that's our aim, the angle between two lines. And as usual, when we are doing coordinate geometry, we're opening up page 18 and 19 on our log tables, and in this case the formula is going to be on page 19. So if we want to find the acute angle between our two lines here, first thing I'm going to want to do is draw a sketch. So I'm going to rearrange this formula. Obviously you do more steps in doing this rearranging. I'm writing it down without steps simply for brevity, so you aren't sitting listening to me for too long. So we rearrange our formula. And we get that first R, we'll call it L1 and L2. L1 can be rearranged like this and L2 can be rearranged like this. And let's draw a very quick sketch. This takes moments to do. We are not talking about very fancy sketches here. So I can see that this line crosses the x-axis, sorry, the y-axis at -2. So I'm going to draw very quick line down for -2, and I can also see that it has a slope of -1/2. So if I run across by 2, I'm going to go down by 1. So if I draw in, you can see this is not fancy stuff, and you can do this even faster in your copybooks because you'll have ruled pages, whereas I am making things up as I go along. So if I run across 2, I go down 1. That's giving me effectively 2 points on my line. So I'm going to go very crudely across like that. That's going to be my L1. And take a different color, and I'll try and do L2. And I have that crosses the line at 2/3, so that's 2/3 of 1, so I'm going to say that's roughly there. And it has a slope of 1/3, so if I run across by 3, I'm going to go up by 1. So run across by 3, go up by 1. Those are my two lines. 2 points, I should say. And very crudely, those are my two lines. And I am going to be looking for the acute angle between these two. So what I'm looking for is this angle here. This is the same as this angle here because they are vertically opposite angles. The obtuse angle between the two of them would be this larger angle here. So that is what we are aiming for visually. And again, the ability to sketch very quickly is an extremely important skill. Now, we have these points here. What do I need for my formula? So if I got stuck in the exam, I'm able to draw my quick sketch to give myself a picture of what it is I need to do. But if I see anything about the angle between two lines, I'm straight away going to page 19, and I'm going to look at this formula. Tan of alpha is equal to m1 minus m2 all over 1 plus m1 m2, and I forgot to write in there's a plus or minus. The plus or minus refers to whether you're taking the acute or obtuse. The positive number from this formula is always going to be the acute angle, and then if you take a negative version of it, you're going to get the obtuse angle. And again, acute means less than 90 degrees, obtuse bigger than 90 degrees for our purposes. Now, let's put this into practice. So what do I see in this formula I see the angle, which I'm looking for, and I see slopes, m1 and m2. So what I want then is the slope of my two lines so I can find the angle between them. So the slope of this line, when I did my sketching work, I actually did most of my work I needed. So m1 is going to be equal to -1/2, and m2 is going to be equal to 1/3. So the sketching work already did some of my rearranging for me, or some of my work for me. Now all I need to do is sub this into my formula. So I know that m1, I'm going to write it down here so I don't make any errors. m1 is -1/2, m2 is 1/3, and I'm looking for alpha. Write down my formula, write down all the information I know, see what I can sub in. So tan of alpha plus or minus -1/2. If you're subbing in and you're in any uncertainty, put everything in brackets. And it will make your life an awful lot easier. And it takes very little time. So I put that in and I neaten everything up and I end up with -5/6 all over 5/6. These divide out and I am left with -1, or specifically I'm left with plus or minus of that. And again, the plus or minus is to remind me that I can get the acute angle out of this equation and I can get the obtuse angle out of this equation. So I have tan of alpha is equal to plus or minus -1. I want to take the positive value of this because I'm asked for the acute angle. Therefore, tan alpha is equal to 1, and hopefully we know that that means that alpha is equal to 45. Or you can take tan to the -1 of both sides, and it would be in your calculator, or inverse tan or arctan of 1 gives you 45 degrees. Now, to point out very briefly, this is going to link in. This formula is actually the same as a formula that you are going to come across in trigonometry. And we already know that the angle between the x-axis, positive x-axis, and our line is the same as the is the same as the slope of our line. So just to point out to you briefly now, this is a formula you will come across in trigonometry, where we have tan of a minus b, so that tan of the angle A minus the angle B is equal to tan of A minus tan of B. Sorry, that should be plus. Tan of A minus tan of B all over 1 plus tan A tan B. This is a formula you are going to come across in the trigonometry chapter. It is identical to the formula we are dealing with right now. It actually says exactly the same thing. We just write it slightly differently because we're using it in slightly different contexts. But they could link the ideas together in the exam, so it's important that you have it in the back of your mind that these are really the same formula. This formula here is along with the other trigonometric identities on page 14 in your log tables, and we will return to it at another stage. But just to note here that it is the same formula as the one we are using to get the angle between two lines. Now, let's look at a second example. Find the equation of two lines through the point -1, 1, which make an angle of 45 degrees with the given line. So let's write this out. I'm told that I have -1, 1 is a point. I'm told that I've got an angle between lines of 45 degrees. And I'm told that I'm dealing with the line 2x plus y minus 2 is equal to 0. I'm going to do what I usually do and draw a quick sketch. And I rearrange this formula and get y is equal to minus 2x plus 2. So if I draw my sketch, I know I cross the y-axis at 2, and I know that as I cross the x-axis I have a slope of -2, so my line is going to look a little something like that. Not a very straight line. And I know that I'm looking at the point -1, 1, which is here. So I'm looking for the equations of two lines that make a 45-degree angle with this blue line and go through the point -1, 1. So we're looking at, roughly speaking, these two dashed lines here. So we have angle of 45 degree, angle of 45 degree, and immediately what jumps out to me is that looks like a right angle in between them. So I think that my two lines I'm going to get are going to be perpendicular. So let's see if that ends up being the case. I'm asked about the equations of lines, so I'm going to immediately write down my formula for that. And I want the equations of lines. I know that I have the point -1, 1 on the line, but I don't know the slope. So what can I do about the slope? Well, I'm also told about angles between lines. So that means I'm going to write down my formula for the angles between lines. So I'm talking through like I would be talking through in my head. If I was in an exam looking at this question, I see I've got the equation of the lines I'm asked about. I see I don't have the slope. I know that I'm asked about the angle between lines, so I write down the angle between lines formula. Now, I know the slope of my first line of L. It's -2. I figured that out by rewriting it in the form y equals mx plus c. So I know the slope of, we'll call M1 the slope I am looking for of my red dashed lines, and I have M2 I'm going to say is my -2. And I know that alpha is equal to 45 degrees. So let's just sub in and see what we get. M minus -2 all over 1 plus M on -2. And I have a plus or minus in that formula, which I dropped. My apologies. Now I rearrange that. Tan of 45 is 1 plus or minus M plus 2 all over 1 minus 2M. I can now see that I've got a plus or minus, so what I'm going to do is break this up into two pieces. And I'm going to come back when I have tidied that up. So I see when I've done that I end up with a slope of -1/3 for one of my lines where I took the positive version, and then a slope of 3 for the case where I took the negative. And I can see, as I expected, that these two lines are perpendicular to each other. This is the negative reciprocal of this, so they're perpendicular, as expected from the sketch. That won't always happen when you're looking at the equation at the angle between two lines by any means, but it will happen when the angle is 45 between them. Now, I now have the slope of two lines, and I know that there's a point that they go through. So now I'm going to use my line equation and sub into that and tidy it for my two equations of my lines. So when I have subbed into my equation of my line formula, I have a slope of -1/3 here, I have a slope of 1/3 here, and my point is the same for both. They're both going through -1, 1. And I can see when I work them down that I get my two equations of my line. And remember, because the angle here was 45 degrees, I ended up with them being perpendicular to each other. My two lines here are perpendicular to each other. And those are the skills we need for now.